All right. Hello, everybody. This is Miss Piekarski. Let's look at our notes. This is a page in our notes. These are three different application problem scenarios with physics. And the first one, you have a person chasing after a balloon. And we know with gravity and helium, and let's say this is a helium balloon, initially the balloon is going to go straight up, right? So that's one of your vectors, okay? But the wind is blowing the balloon, and it's going to cause the balloon to drift this way. That's another vector. When you add those two vectors together, you're going to get the resultant, or the actual path that the balloon takes. Okay, that's one of the examples. Another one is a rowboat. This is a problem that you've probably seen on a SAT question. This is lots and lots and lots of different types of tests, standardized tests love to give you this problem. There are lots of different ways you can find this out using geometry or other formulas that we've already covered, but using vectors is probably the easiest. Okay, so with example B, you have a boat. The person rowing the boat is going to row or keep the boat pointed straight across, but the current of the river is going down. It's going to push that boat so it's not going straight across. It's going to go down. So the river current is another vector or another force acting on the actual location of the boat and how far and what direction the boat's going. So this resultant is the actual velocity or the actual path that the boat will take. Now another example is for C, you have a dog walker and the dog is attached to the leash. Well, the owner of the dog is pulling back on the leash. So the force for this vector is going this way, but the dog wants to go and chase this cat that's right below him. So the dog is pulling that way. Well, the path that this dog is actually going to take is this one because of the different reactions or the two different forces that are affecting the direction of the dog. Okay, so those are three different examples. If you recall from earlier in our units, we had the two different ways of graphing something. You had tail-to-tip method or the parallelogram method. Well, if you look at your example A, this is an example of the tail-to-tip method. You're starting, one vector is starting here, it's going up, and the location or the other vector is going to start at the tail or the end of your first vector, and it's going this way. So example A would be a tail-to-tip graph. Example B would also be tail-to-tip graph, but example C would be your parallelogram. Okay, so example C is your parallelogram example. So notice that they're both starting at the origin of the dog. Both vectors are starting there, and they're going different directions, okay? And then the resultant is going to be this path here. Well, if you wanted to find the other parts of the parallelogram, it would look like this. So that's how we're getting this resultant. So example C is an example where both vectors are starting at the same origin. Example A and B are your tail-to-tip examples. Okay? Either way, whether you're doing parallelogram or tail-to-tip, all those vector formulas that we've covered so far still apply. Okay, so let's look at the examples on the worksheet. Oh, I forgot. Let's go over this real quick. This is also in your notes. If you don't have your notes with you, write this down. You can fill it out when you come into class. Okay, so if you have two forces acting together, you'll get a resultant. Here, F1 and F2 are vectors for the forces acting on a moving object. Okay, we're going to make them vectors. They're just two different forces acting on a moving object. Okay, and R is the vector showing the actual resultant, velocity, and direction. Okay, the main thing here is we are changing magnitude to velocity. Okay, all right. Now, the direction for each vector is still a rotation angle measured from the positive x-axis. The magnitude for each vector is often associated with a speed or a force. So your speed, you might be going 60 miles an hour, or force, you might be putting, 100 pounds of pressure on something. Okay, so this is more of a physics application of our vectors. All right, so now let's look at our examples. So for problem number 1, this is in the worksheet. In example A from your notes, suppose the balloon rises U at a rate of 6 miles per hour. That's our speed there, or our magnitude. So the balloon's going to rise 6 miles per hour. Just put 6. You don't need to use the units of measurement. But the wind is blowing at 8 miles an hour. So our our magnitude for the wind is 8. It's blowing from the west. Well, if it's going from the west, that means it's going from the west, it's going east. So what direction is that? You're going 0 degrees, okay? So the wind has an angle of 0 degrees. Find the actual speed of the balloon and the angle its path makes. So notice they didn't tell us that the balloon is going straight up. But we know if something's rising, if a balloon is rising, as long as there's no wind, the direction will be 90 degrees there. Okay? So we have our magnitude and direction. We can find our components. It will help if you look at the picture again. With a magnitude of 60 and direction of 90, you're just going straight up. With a magnitude of 8 and a direction of 0, that means you're just going straight to the right. So we don't even need to use our component formulas. We can just say that our components are 0 to 6 for the for the balloon, and then 8 to 0 for the wind. Now, both of those vectors are working or pushing on that balloon. So the actual path for the balloon, the actual components, I'm just going to add these two together. They'll be 8 and 6. Whoops. I didn't want to show that stuff, sorry. Let me see, 8 and 6. Okay, now I'm going to use those components to find my direction. So I'll do inverse tangent. I think I did the curve a little backwards here. Inverse tangent of 6 over 8, that's my formula. Inverse tangent of y over x. To find my direction, I'm going to plug it into my calculator, and the calculator tells me that the direction is approximately 36.87. If I wanted to round to 1 decimal place, I'd put 36.9. Okay. Now I'm going to use my magnitude. So I'm going to have the square root of 8 squared plus 6 squared, which is 36. And when I plug that into my calculator, I'm going to get, let's see, 10. Yay. Nice even whole number. Okay, so what does this information tell us? Okay, this information tells us that the balloon is actually going to be traveling at 10 miles per hour at an angle of 36.9 degrees from the horizontal. Okay, so this resultant just tells us how fast the balloon is traveling and where it's going. Let's look at example 2, or example B, problem number 2. You have a boat heading directly across the river, so I know my direction is going to be 0 degrees, and the rower is rowing at 12 miles per hour, so my magnitude is 12. The boat's current is flowing at 17 miles an hour. So the current is 17, and it doesn't tell me, but the water's going straight down, so the direction would be either negative 90 or 270. Either one of those will work. So now I need to find my components. Again, it'll help if you draw a picture. Your magnitude, you're going straight this way, and for the current, it's going straight down. So again, we don't even need to use our formulas for our components. We can if we want to, but since most of you don't have a calculator, it doesn't matter. Because I'm going straight across, I know that my x is going to be 12 and my y is 0. And for the current, I'm going straight down, so x is 0 and y is negative 17. I'm going to add those two components together and I get 12 and negative 17. Then I'm using my inverse tangent formula. Let's do inverse tangent of negative 17 over 12. And I'm going to get the angle negative 50, whoops. Let's see. Negative 54.8, was that what it was? Yeah, approximately 54, negative 54.8. All right, so that's my direction. Now let's find the magnitude. The square root of 12 squared plus 17 squared gives me my magnitude of approximately 20.8. Notice they did not put it in exact value form. For my application problems, go ahead and round your answer, because telling somebody, hey, the boat's traveling the square root of, I don't even know what 12 squared plus 17 squared is. It's not going to get, you tell somebody that and they're going to look at you like you're crazy. But if you tell somebody that, hey, that boat is actually traveling approximately 20.8 miles per hour at an angle of approximately 55 degrees below the horizontal, or 55 degrees from, I don't know, down, whatever, however you want to word it. This part makes more sense, okay? So in these application problems, it is okay to go ahead and give me a rounded answer for your magnitude. All right, third example, and then we'll be done with this video. You have example C. You have a dog owner who's pulling her pet leash with 78 pounds of force, and the dog bears down with a force of 40 pounds at an angle of 120 degrees from the leash. Okay, so that gets a little bit complicated. We might have to go back to our picture to look at that. Or I can draw it really quickly. So the dog's pulling straight down, and the owner, you know what, let's go back to the picture. Let's see, so yeah, the dog's pulling straight down, the owner's leash is going this way, and we need to find the resultant. Okay, so let's look back at our word problem. Whoops. Okay, here's our word problem. Here's our dog's right here. The leash is being pulled back this way. Let me see. So our dog is going negative 90 degrees is the direction on the dog, and the dog's force is 40 pounds. The dog owner, the woman, has a force of what? Where do we see? 78 pounds of pressure. Okay, and let's see, how did they word the degrees? Okay, so the dog bears down with a force of 40 pounds at an angle of 120 degrees from the leash. All right, I'm going to just uncover the answer, and then we'll look at how they got that. All right. So if the dog's pulling down, this angle, this big angle here, is 120 degrees. Okay? But we want to know what is this little tiny angle here, and that's where you get the 30 degrees. Okay? That one can be a little bit confusing. That's why I just showed you the answer and then explained how we got the answer for that one. All right, so it looks like the components are already on the board, they're already on your paper for the dog. Let's find the components for the woman. And this one we will need to use our formulas. So to find x, whoops, thought I changed it. So to find x, we're going to do 78, which is our force, times cosine of 30 degrees. And then to find y, we're going to do 78 times sine of 30 degrees. Those are our component formulas. Okay? And let me see, I can't remember how far they rounded. They rounded to, looks like 2 decimal places. All right, so those are my components, and I get those from plugging it into the calculator. Now, I'm going to add these two components together to get my resultant, and I get -1 and 67.5. Then I do inverse tangent of -1 and 67.55 for my direction. And I get my direction is -1 degrees. And then my magnitude, I do the square root of 67.55 squared plus -1 squared. And I get approximately 67.56 pounds of force. Okay? So what that means, let me delete all this. Okay? So let's look at what that information is telling us. And it's telling us that the dog is being pulled with 67.56 pounds of force with a direction of only about -1 degree. So he's not going to get the cat. The dog owner's protecting that cat. All right, so this is the end of the video. Please make sure you have this page filled out. Do not leave it at home. Make sure you remember how to set up these tables here. They will help you tremendously, okay? Your first column is the labels of the vectors. Then you find the magnitudes, the directions, and then the components, okay? Make sure you remember that after you find the components, you use, whoops, let me change that to pin. You're going to use these components to find your direction here and your magnitude. Okay, you cannot add these together. If you add those together, you're going to get the wrong answer here. If you add these together, you will get the wrong answer here. You have to use your components. Do not forget that.